Okay, I've started it now. We're all trying to figure out an estimate for the IROC of velocity at 40 seconds. Michelle, what interval are you going to use to find an estimate of the IROC at 40?
I don't know. Can you help me? 70. I don't know.
So what does IROC mean? Change in Y over change in X, right?
Yeah.
Okay. So what is the change in Y that we want if we want to know what's happening right at 40?
70.
We need a, go ahead.
Oh, I don't know. What were you gonna say?
I was going to say we need to have a change, right? So we have to have something minus something over something minus something. So we just can't take 75 over 40, can we?
No.
Because that's not a change in anything. So we talked about being on either side of the thing we want, right? What would be the interval on either side of 40?
70. I don't know.
You see how 35 is the time right before 40. What's the time right after 40?
45.
Beautiful. So that would be the interval we would look at.
Oh.
We'd look from 35 in the X to 45 in the X. Those numbers would be in our denominator. What numbers would be in our numerator? Somebody else. Or go ahead, Michelle, if you know. Perfect. Do you know what numbers would be in the numerator, Michelle?
Is it I don't know, 75 and 40 or 50?
It's the 60 and the 81, the Y values that go with the 35 and the 45. Does that make sense?
Okay, yeah.
So Cynthia, which one goes which? Which one goes first?
I think the 60.
Okay. And the 81 would go second?
Oh, shoot. No, it's flipped. Sorry.
So 81 should go first?
Wait. No, I think I was right. Yeah, because yeah.
Because the 60 goes with the 40, doesn't it?
Yeah.
And the 81 goes with the 35. So as we look, these should match up numerator and denominator. And so let's just do the math really quick. What's 60 minus 81? Well, that would be negative 19, wouldn't it? And 45 minus 35
10.
Be 10. Simplifying that, that would be negative 1.9, I think. But all importantly, what are the units?
Mister, that's negative 21, not negative 19.
Yeah, you're right. Thank you. So that would be negative 2.1, not 1.9, wouldn't it? Pretty close, but not exact. Now we're good. What are the units of the numerator?
Feet per second squared.
That's the whole thing, but just the numerator was feet per second. Denominator, seconds. So our estimate of AROC would be negative 2.1 feet per second squared. And last thing, what does this negative sign mean? Caleb, do you remember what that negative sign tells us?
That the IROC is decreasing.
Almost. This is the IROC. The IROC tells you the original quantity you were measuring. What was that original quantity? It was velocity is decreasing. Okay? So that's what the negative sign tells you. This negative and that decreasing are linked. Okay? Now I want to check our time, 11:25. It's 11:04. Barrington, Michelle, Paul, others that I haven't checked in with. Is this helping? Like, we spent a little bit extra time, but I'm fine to do it if it gets us to a better understanding. Michelle, was that what you needed to feel better about things?
Sorry, yeah.
Good, glad to hear it. So what I want us to do now, I want you to see in the content library, most of my notes. If you ever want to look back and say, oh, like, what did we do yesterday? Oh, we'll go to 831 and look at the lesson. That's where our notes will be. These will always stay there. But I've also added a tab that says answer keys. So like for 825-26, that modified homework, I have an answer key. This is especially helpful for somebody like Arlie, who may have joined late. Like, she can go by and see what the homeworks were and what the answers were. 2.7, homework key. We revised 2.8, but here are the answers. Yesterday, that's what I want to look at for a minute. I want you to look at your homework, and I want you to look at my answers for the first three. Do you have any questions on number 1, number 2, or number 3? If you have a question on 1, 2, or 3, put your hand up so that I know what your question is and we can spend a little bit of time talking about it. Okay, so Barrington, you had some trouble last night, but you had these first three okay? Okay, cool. Number 4, draw the tangent line whose slope represents the IROC, or derivative of the graph, at x equals 3. So if you look at my graph, that blue line that I drew is my answer to number 4. Then I want to look at number 5. It asked, make an estimate of the derivative at x equals 3. By finding the slope of your tangent line, you'll need to do the grid to use the grid in the background since you have no equation. So what I did is I used that grid to say, hey, I think that blue line is going down 2 over 1. And so I came up with a slope of -2. That was my estimate for derivative for number 4. And again, my units were miles per minute. That was for number 5. Number 6, draw a line tangent whose slope represents the IROC at 1.5. So all I did is I went over to my graph where time was 1.5. I went up to see where it touched the graph, and I tried to draw a line that went through that point and was parallel to the graph. And then my last answer, part B, was where I used the average rate of change at intervals very, very close to 1.5. I was really close to 1.5 on the right and on the left. Raise your hand if you do not remember how to make your calculator help you with a question like this. My answer was about 3.54. And my units were miles per hour or miles per hour squared. Because when I looked at the change in y over the change in x, we had miles per hour on the y and another hours on the x. In the chat, I want you to be honest and thumb up either of these two statements. Going over the homework was helpful, or not helpful, went too fast, maybe I didn't do it, so didn't do it, so it didn't help, whatever. That'll be the second one. Just trying to figure out if we should continue to do some of this in the future. Okay, that helps me. Thank you, guys. So now what I want you to do is I want you to look in your student page. Where do you find your student page? I can see all of yours. I'm just going to look at Fernanda's. She should have period 3, 1.9 homework. I want to make sure that everybody can find their period 3, 1.9 homework in their student page. So just look for that for a minute. Raise your hand if you weren't able to find your student page. Okay. So this is what is due on Thursday. We won't meet tomorrow, so you've got 2 days to do this one. And for all the rest, they'll just be graded on effort so far. Like, did you try it? Are you doing your best? This one is going to be more graded on your answers and how it went. And it's not really like a take-home quiz, but it's like a homework assignment that's graded for more correctness. And we're going to start it together in class, and we're going to talk about it so that you have an idea of how to do some of them. So I want to make sure that everybody can find it. And then I want Juan to just read the very first problem to us, and we're going to talk about it.
Okay. A pendulum hangs from the ceiling. As the pendulum swings, its distance, d, in centimeters from one wall of the room depends on the number of seconds, t, since it was set in motion. Assume that the equation for d as a function of t is d equals 80 plus 30 cosine pi over 3t, or t is less than or equal to 0. Make sure
Other way,
calculate
greater than 0, greater than or equal.
Greater than 0, sorry.
No, it's okay, but beautiful. Like, you did a great job. Keep going with the very last question.
You want to find out how fast the pendulum is moving at a given instant, t, and whether it is approaching or going away from the wall.
Great. Okay. That's our ultimate goal. And then number 3, Cynthia, what does number 3 ask us?
Find D when t equals 5. Make sure your calculator is in radian mode.
Okay, so now, open discussion. I wanted this to be in our collaboration space, but first period, it was so hard, it took us so long to get there. And when we tried to get there, people weren't in the place they needed to be, and so it just was time wasted. And until we can make that time more purposeful, I don't want to waste time because our time is too valuable. So we're going to do it in a larger setting. Who thinks they have an idea at how they might tackle number 3? We're looking for D when t is 5. Go ahead, Cynthia.
I would plug in t inside the parentheses of the pi over 3.
You're saying, hey, like, I know D is equal to 80 plus 30 cosine pi over 3, and where that t is where you would put 5. What do you guys think? Yay or nay? Does anybody agree or disagree?
I agree.
I do too. I think that Cynthia is a sharp cookie. She's totally right. I am going to suggest a shortcut, though, in that I'm going to actually plug this into my calculator because I think it might be helpful to have this function in there later so that we could find average rates of change if I was asked for it, etc. So I want everybody to do that with me. 80 plus.
I can't see your calculator.
Really?
It's like zoomed in on the problem.
Because it was showing up on my screen where I thought it should, but thank you. Do you see it now?
Yeah.
Okay, great. So all I'm doing is I'm going to my y equals, and I'm plugging in 80 plus 30 cosine. Where's the pi? Well, it's going to be above the little caret symbol. Divide by 3. And I'm not going to plug in 5 here. I'm going to plug in x. So it's pi over 3 times x, and I'm going to close my parentheses. And then I'm going to go out to the normal screen. So second quit. How do we know if our calculator is in radian mode? Well, we go to mode, which is right next to the blue second. Usually they are in radians, but if you've had like a physics class or something, degrees could be highlighted. So we want to make sure that radians are highlighted. Okay. Does anybody remember how I could get that y function at 5? Do you guys remember the keystrokes to bring up y1? Betsy, do you remember how to do that?
Bring up y1.
Yeah.
You go, you press alpha, then trace.
Perfect. And I want this y1 at 5, so I can plug it in. Sure enough, what does that 95 represent? Patton, what does that 95 represent?
I don't know.
Somebody else. Caleb, do you know what that 95 represents?
I don't know either.
So let's go back and read. A pendulum hangs from the ceiling. As the pendulum swings, its distance d in centimeters from one wall of the room depends on the number of seconds t. What does that d represent? Distance in centimeters from the wall. It's like in our case right now at 5 seconds, that d is 95 centimeters. That's all that represents. D is in centimeters, and it's a distance. So now I want everybody to just read number 4 on their own. If you were doing this and I wasn't here, how could you find the average rate of change of D with respect to T for the interval 4.9 to 5 and 4.99 to 5? What would you do? Buddy, what do you think? How would you find the average rate of change from 4.9 to 5?
I'm not sure.
Are you sure? Like, what is an average rate of change, buddy? It's got to be a slope, right? Change in what over change in what?
Change in y over change of x.
Very good. So in our problem, what are the y's representing and what are the x's representing?
The intervals?
Well, our intervals will be time from t equals 4.9 to 5.0. So we're really looking at our change in distance over our change in time or D at 5 minus D at 4.9 all over 5 minus 4.9. And of course, this numerator can be found just like we found that 95, can't it? On our calculator, it would look like y at 5, y1, minus y1 at 4.9, all over 5 minus 4.9. What is going to be the difference between an interval of 4.9 to 5 and 4.99 to 5.0? Which one of these answers is going to give a better estimate of our IROC?
5.00 and 4.99.
Why?
Because it's closer, I guess.
Yeah, that's right. This is going to be our better estimate. And I just want to scroll down so that we can look at this other problem here. This kind of goes back to our do now and lesson today. A mass is bouncing up and down on a spring hanging from the ceiling. Its distance, y, here's the distance y, in feet from the ceiling is measured by a calculator distance probe every 1/10 of a second. And the values are given in the table. Estimate how fast y is changing at t equals 0.3. How could we use our table to figure out the change in y over the change in time at t equals 0.3? Jacob, what do you think? Or Gavin? I haven't heard from you guys yet today. How could we use that table to estimate the derivative y prime, or the IROC of y at t equals 0.3? Gavin, Jacob, any ideas? Michelle, do you remember if we're looking right at 0.3, what numbers are we going to want to use to estimate the IROC right at 0.3?
Wasn't it 0.2 and 0.4?
That's right. We would use the numbers on either side. There would be our delta x. There would be our delta y, wouldn't it?
Yeah.
So anyway, like that hopefully helps you tie together what we've been learning over the last couple days to today's homework. There's plenty of left for you to do. You're welcome to work together, but if you work with somebody, right on the top of your work in your student page, hey, I worked with Caleb and I'm Juan, or whatever, so that I know, oh gosh, like Caleb and Juan's work looks really similar. Well, that's because they did it together and they told me that, and that's okay. Okay. We should all get to lunch, but I will stick around in case there's questions. Like, oh, Mr. Efron, I want to use 5 minutes of my lunch because I'm dying to get an answer on this question from last night's homework or whatever it was. But otherwise, We don't have class tomorrow because it's Wednesday. And remember, tomorrow's schedule is weird. It is not normal. I will put a post in the Teams kind of chat so that you can see it should come to you, just to remind you when we meet tomorrow, because I don't happen to remember right offhand. Do you feel a little bit better about tonight's homework now that we've started it?
Yes.
Good. Okay. Find somebody in class that you like. Hey, I've been working on number 5. What do you think? I'm stumped with that one. That way you've got somebody to go to. Have a great rest of your day, guys. Good job today.
Bye, mister.
Mister. You do
Bye,
as well.
mister.
Unmute and say goodbye. Bye, guys.
Bye, mister.
Bye.
Bye.
Hi.
Bye. Thank you, Paul.
Bye, mister.
Bye, Angel. Angel, how was today for you? Patton, are you catching up okay?
Yeah, I'm doing just fine.
Okay.
And also,
good.
what's it called? My name is pronounced Peyton.
Oh, I'm sorry, Peyton. Thank you so much.
Yeah, you're all good. I didn't want to say that in front of the
No,
class.
no,
'cause I
it's
know
all
that
good.
can be-
If I screw it up again, I'll just say, hey, I'm just like Peyton Manning, and I'll be like, oh yeah, are you rich like him too? No, but just say something funny like that, and I'll laugh and probably remember better.
All right, I will do.
Thank you, Peyton.
Today was a great lesson, by the way. It really helped me catch up.
Oh, good. I'm glad to hear it.
Thank you, mister.
You're welcome.
Bye-bye.
Bye.